Hi, my name is Wouter Remmerie and I'm the founder of AirShaper. In this video on airplane design, someone else will be doing the talking. Some time ago, I met Yong Wook Sin, who works at the Peugeot Design Center. As it turned out, even in his free time, he likes to create cool stuff, like a futuristic electric airplane. Nice
Hello,
to meet you
Wouter.
again.
Okay. Yes, I thank you very much for your invitation. It's a real pleasure to talk with an expert in this domain, on the other side of the continent, and able to talk about our passion and
Yeah,
our share of passion.
likewise. Car design and aerodynamics. It's a good
Absolutely.
combination.
Yes. Well, at the moment, as you know, I'm designing aircraft for fun, a
Yeah,
personal hobby.
yes.
There are people who design things for with the papers and RC planes and RC cars. In my case, I like to design things with the with CAD using because I'm quite able to able to create objects in 3D, and because it's such a convenient tool. And when I design things, even though I'm an industrial designer, I would like to make things that works, because to me, just design things for the sake of the way it looks is not challenging enough.
Yeah, indeed.
So yes. Well, so here I am, and the things we have been sharing for the past few days, I think a month now almost. It's been very interesting.
Yeah, maybe you can show some stuff. If you want, you can share your screen. There's a button at the
Yeah.
bottom right of
Yes,
the web
but
interface.
present now, is it?
Yes, that's the one.
In the window. Should it be, or should it be?
Or full
Wait a
screen, you can choose. Maybe the full screen is the easiest, and then you can switch between windows and still share.
Okay. Yeah, okay. Present now, your entire screen. So it should be like this.
Okay. And there should be a...
There's a-
Okay, I can see your screen. Perfect. It's loaded.
Okay. So this is not the one.
Yeah. So this is our theoretical discussion on
Yeah, that's
lifts.
right. Yeah, thanks very much for the things you have sent me. I've been reading it through. I can absolutely get the idea, and the website of the airfoil design. It's very comprehensive, though I can't precisely link the figures to what's in the website, but I get the general idea. The
Yeah.
general idea is there, so I can understand the concept.
Yeah.
I think maybe I should switch the screen because I have my main screen
Yeah,
on the other
please.
side.
That would be nice.
This thing,
Indeed.
yeah,
You have a dual screen probably.
yes, to this one actually, yes, because on this one I have the
Oh,
plane,
nice.
yes. So
So it's in
this has
Rhino.
been my,
Okay.
yeah. Rhino is a great program because even though I'm just it's a program that I've been using it for over 15 years now, and I
Okay.
have
Okay.
taught myself because sometimes as a designer I'm very frustrated that things are not going as I would like to. So I decided to take the model myself, even though we have, of course, the professional CAD designer.
Yeah.
I like to take things on my own hand and on my spare time, modify and above all experiment the actual physics, the reality of 3D.
Yeah.
And I tend to find lots of answers just by working it myself. So this is basically a solar plane, electric plane,
Yes.
in the ultralight category. So the planes should be around 600 kilogram maximum. When I look at the way ultralights, especially from countries like Czechoslovakia, is developing with
Yeah.
very weight materials like carbon fiber, it's astonishing what they can do with 300 kilogram.
Yeah. And
And
still for two people then, like in your
and yes,
concept.
and still for two people, and they can cruise at 200 kilometers an hour. On top of that, they have retractable landing gears, and I really don't know how they do it because
Yeah.
in
It's impressive.
in car design world, making cars that approaches 500 kilogram is no longer possible.
Yeah.
You know,
Indeed. For safety is the main reason, I guess, for that weight
yes,
increase.
I think so. But Yes, but when you look at Formula One cars, of course, it's not the same budget, but
Yeah.
Formula One cars can crash into concrete walls at 100 kilometers an hour and with no airbags,
Yeah.
and drivers can just step out. So I don't know, maybe in car manufacturing we're not trying hard enough.
Yeah. Yeah, indeed.
Maybe that's simply the reason. Anyway, I've decided to take this challenge of making a ultralight category aircraft, and with two-person, I can actually show you the people here
Okay.
sitting like this, and I have I've made the airplane as compact as possible for aerodynamic and weight reason. And I've used the real ergonomy from 50 percentile to a larger 90 percentile person, which is here.
Yeah.
And make sure that these people with the H point fixed, which means that the controls will be adapting to the pilot instead of a pilot moving around. I think
like in supercars where the seat is
that,
fixed.
that's right. Yes, that's right. Yes, I think it's kind of a I don't know if lightweight ultralight airplanes has adjustable seats. I don't know, but anyway, you have to apply to different sizes of the pilot.
Yeah.
So and so this is and another thing I wanted to do, even though in terms of production is not maybe too feasible, is to make a canopy with a very large glass area, as you can see here.
Yeah.
And I think I have some. I think I have some images here. I think. Wait a minute, just a moment, please.
Which is mainly a challenge for structural stiffness, then I guess.
Yes, yeah, of course. But being in the front part of the plane, which is away from the wing, I don't think there's that much of an importance with the with this structural stiffness. So I have some image of the plane here, actually.
Okay. So these are the renderings you showed us before. They look fantastic.
Yes. So this is the rendering. So these are just the test renderings. They're not final renderings. In this case, I have rendered the wings and some part of the aircraft in black, which corresponds to the solar panels. Okay. And the surface area of the solar panel should be around 13 square meters.
Okay, and would that be enough to keep flying, or just
yeah,
to extend the flight?
This is something that I would like to find out, because when I imagine that this aircraft will be coming out in 10 years' time, I presume that at that horizon, looking at the way the solar panels efficiency is progressing, we may have solar panels with 30% efficiency, which means from 1 square meters, it can produce 300 watts.
Yeah.
So when we calculate the surface areas of wing and solar panels, which is about 13 square meters, it can produce about 3 kilowatts of energy in optimal condition. Okay. So I don't know, is 3 kilowatt is about 4 horsepower. I think it can at least extend the range of flight. I think that's my purpose.
And what's the normal power output of the motor you had in mind?
I have looked at various examples, and I think it depends on how efficient the airplane is. To sustain flight, I think I would have to find out and ask some, look at internet, ask some experts how much power is really necessary to keep it in flight, to keep a sustained flight.
Yeah, and you put the propeller around the fuselage. Aerodynamically, that's quite interesting. Maybe you can tell us a bit more about that setup.
Yeah, I think it's an area I think you can maybe you can tell me more about that. But being yes, I thought that was a very neat idea, because having a propeller in the front, which is a typical normal propeller aircraft, is sort of it's blurring the vision. It's front of you, and it also is not very elegant. And I thought it would be a good idea to I mean, putting the propeller at the back is nothing new. There are many aircraft that does that, but it's not. You have to create an extra structure, extra part that comes out of the fuselage, which doesn't look clean.
Yeah.
And I thought maybe for aircraft, electric aircraft, we can try something new. And what I thought of was an O-ring. I can show you here actually. When what happens is that it's an electric motor that's like basically a giant ball bearing.
Yeah.
Okay?
Yeah.
And what this does is that it can allow cables and other structures to pass in the middle.
Yeah, and your structural stiffness for the tail goes all the way through the center inner part of the rotor.
No,
Okay.
no, it doesn't actually.
Okay.
Actually, the housing of the electric motor itself, which is this, well,
Yes.
the center part works as a structural part.
Okay.
So,
Okay.
so basically, the main fuselage here and the tail is attached via the motor.
Okay. Yeah. Yeah.
In Formula One, for example, in racing cars, the engine block works as a structural part
Yeah,
that
indeed.
holds the suspensions to the body. So in this case, the electric motor, the housing, the principal housing, actually this one is not the final version, but housing on the bottom, which is non-rotational part, holds the main body to the tail.
Yeah. Yeah.
And the outer ring, which is here, is the part that holds the solid magnetics.
Yeah.
And the inner part holds the coil, and
That's
the outer part of the motor turns with the propeller. So what this gives is potentially a very clean, totally integrated propeller with the fuselage. I think this is really the original part of this concept.
Yeah.
And to push the concept further, what I'm going to do is to split the motor in two, making the coil part on one side of the rotational part and the magnetic on the other side, and put the counter-rotating electric motor with two different sets of propellers.
Okay.
So what happens is we'll have two sets of propellers that counter-rotates, which I haven't done yet, which I have it in my mind, but I haven't put into 3D yet.
Yeah, to increase the thrust without increasing the swept area of the duct that you have in mind.
Yes, and also to get rid of the torque effects of the motor.
Yeah, yeah, indeed,
yes,
indeed.
Yes.
Okay. Yeah, I like the concept because first of all, with light planes like this, the center of gravity is very important. So instead of putting the rotor all the way at the back, which would give it an inclination angle, this one is closer to the center. And also, like you said, if you have a propeller at the front of the plane, not only does it impair visibility, but also it creates dirty turbulent air that is then pushed all over the plane, which can increase drag. And the way you're doing it, you kind of create an underpressure towards the cockpit where you get a nice and clean, more laminar flow that is pulled over the cockpit where the people are. And only after the last part, only there do you get some turbulence. So this
absolutely, yes. I think turbulence will certainly affect the cockpit area and also over the wing, and also it will create unnecessary noise, I think.
Yeah.
I would like to have an aircraft that is very quiet, that is very sort of silent cruising, and I thought that is definitely one of the advantage to have electric motor placed at the back.
Yeah.
And also because of the turbulence, I've also split the tail at the back. Before, this tail was much closer together, but I have made this a slight elongation so that the aerodynamics of the rear tail is not disrupted by by the propeller.
So for some more stability during the control of the plane, because that's what the flaps in the rear are for, indeed. Okay.
Absolutely. I mean, if I look at it like this, as you can see that this is the turbulence area, and the rear tail is out of this zone.
Yeah, indeed.
Yes.
And then the main wings, they feature a slight upward angle as from the middle toward the ends. That's probably to get a little bit of more way when you're maneuvering during landing and takeoff?
Which part are you talking about?
Well, the main wings, they go relatively horizontal, and then when you get to the middle, they kind of increase their angle a bit towards the outside, so the tips of the wings are higher above the ground than the center parts.
Oh yes, I have flown a lot of gliders and RC planes, and I know that having an angle gives stability of the plane.
Yeah.
I forgot the technical name for this, but normally I would put it from. I can hear some.
Oh yeah, sorry, that was me. That was me. No, you're right. It's the dihedral setup, for example.
Absolutely yes. Yeah. But instead of putting it from the center, I decided to keep a horizontal place because of this the solar panel. I wanted to have some area which is completely vertical.
Yeah.
In relationship with the sky, because if you make a angle immediately, depending on the position of the aircraft, the amount of sunlight that will be hitting on the wing can be reduced. So for that reason, I have decided to keep a fair amount of flat place and started to have the dihedral angle from the middle of the air from the wing.
Yeah.
And well, that's my theory anyway, but that was the reason.
Yeah, the compromise, of course, is different when you need a solar-powered airplane versus a conventional airplane. So it would make sense. And they also have the wingtips at the end of the wings to reduce the wingtip vortices, probably.
Absolutely, yes. I have read lots of articles about it, that how we can reduce the vortex, the drag of the turbulence at the tip of the wing. So, and also it looks good. I have to say it adds, you know, when you look at all the passenger aircraft these days, when I sit in the airplane, I can't help looking at it, because they look, not all of them, but many of them look very, very beautiful.
Yeah. You even have double winglets these days, or wingtips,
yeah.
which
yeah.
split them in two and make them even more efficient.
I see, but the one that goes down, yeah?
Yeah.
I see, yes. I've noticed that actually before the wingtip that goes up, before I've noticed many airplanes like the A10 Fairchild. I don't know if you know the tank killer that has a wingtip that goes down, and I believe that is done is because it creates extra lift. I believe.
Yeah, it depends a lot on the angle of the winglet itself, but indeed it can create extra lift because you have the high pressure zone at the bottom, and if it works against these wingtips, if they're at a slight angle towards versus the vertical, that's what increase the lift of the overall wing. Yeah,
that's what I've gathered. Yes. So well, here you go, and of course creating these kind of objects on 3D is all fun. But not knowing how it will really perform it's a big frustration. And of course, company like yours, where you can test the aerodynamics quite quickly. I was very surprised how fast you can test it overnight. It sort of answers lots of questions and takes away the frustrations as well.
Yeah. Indeed, coming back to the simulation, one of the things we noticed is that it's a very streamlined plane, that's for sure. That's the first thing we saw. The second thing we saw is that we saw a good correlation between theoretical calculations based on airfoil theory and what we saw in simulations. And the third one is that the landing gear, for example, would be one of the areas to maybe further reduce drag, but making them retractable would also increase the weight. What do you think about that trade-off?
That's exactly what I thought, but precisely for that reason, I've been experimenting a few ideas here, like this one. What worries me, even though it is just a 3D world, is the weight. And when I look at all this mechanism, you know, and how heavy those can be, you know, I don't know if you know, what would be better, to increase the weight and complexity, and also taking a lot of internal space, or have, you know, extra drag on the airplane.
Yeah.
But in this case, I really don't know.
yeah, indeed. And it's also a balance towards safety, because the wider you make the wheels, the safer it is to land and take off, but the more weight you add to the plane, I guess.
Of course. Another thing I heard is that the planes with retractable wheels are about 35% more expensive to maintain because there are so much more things to be inspected every year.
Yeah.
And another thing is that, believe it or not, there are lots of accidents. There are a lot more accidents with retractable wheels because pilots do forget to extend
really?
it. Yes.
Okay.
In fact, YouTube is full of videos of planes crash landing without wheels, not because they are broken, but because simply because pilots have forgotten how to extend it.
Okay, so it's not always safer then.
Yes,
Okay.
I mean, if I were playing an airplane for myself, I think I would choose a fixed landing gear.
Yeah.
Anyway, that's just a theory. But
That's
what I'm going to do anyway is for just for the pure challenge of it, I will go for a system. This is not the right one. I have the second one that will because the body is quite streamlined and quite compact. It's going to be very challenging, but I will design a very convincing retractable landing gear because it's a challenge, and I like challenge.
yeah.
Challenges. I'll forget about the weight, how much you weight. I don't know. I'm just gonna design something that works on this package.
Yeah, it depends a lot on your target cost. If it's a low budget plane, then probably some materials are excluded from the equation, which makes it more difficult to make it lightweight again, probably.
Yes, I think unbelievably, when you look at the price of the most high-end ultralight aircraft these days from Switzerland and also from Czechoslovakia,
Yeah.
they go beyond 200,000 euros. They go well into 250,000 euros.
Okay.
So, but I still, yeah, but that's still not bad, I think, compared to some supercars that's been made these days. It goes well
That's true.
into 500,000.
At least, that's
Yeah,
for
at
sure.
least, yes.
Well, talking about cars, this is your hobby, and your daytime job is designer at the Peugeot Center of Design. How does it relate in terms of the freedom that you have, the satisfaction that it gives you, the visual freedom that you have, and the safety regulations that come into play? Is it very different, or is it in the end the same process?
I think we have different challenges, but what is most challenging in the car design world is the price. We have to make first we have to. I think the first thing is the price, and this price is very much related to mass production.
Yeah.
And because cars like 208, we have to produce, in such a ridiculous amount of number. We produce 3 million cars a year, or over 3 million cars.
Okay. Yeah.
Of course, it's not only for one model, but a popular model, we have to produce several hundred, 1,000 units per month. And to do that, everything about the design and engineering have to be geared towards mass production, and that's what makes car design so extremely difficult.
Yeah.
In case of airplanes like this one, you will probably produce in maximum few hundred a year, not even, maybe 50 units. And because they are mostly handmade, the manufacturing is so much more easier.
Yeah.
So I would say, mass-produced car design it's somewhat more difficult. And another thing, of course, is that in times of when the first Citroën DS was developed in the late 40s and 50s, the complete team, the engineer and designers and all the development, the team was around 50 people, 50 specialists.
Really, that's it.
Oh yeah, that was it. And if you look at the original Citroën DS, it was an incredibly complicated car, a sophisticated car. But these days, you're talking about minimum 500, experts to develop a mass-produced car.
Yeah.
And that makes things very difficult because you need approval, you need to consult them, you have to check in every single details. Often when you look at the car used these days, often cars were recalled, which will cost several millions, or if not tens or hundreds of millions of dollars of damage to the company because of one wrong nuts and bolts, one little components.
Yeah, indeed.
So it's a very, very high risk, very challenging work.
Okay, yeah, and if you talk about mass production or even pre-production, what would be your dream, or maybe not just a dream, what would be your plans with your plane?
First of all, I would like to have, at least in 3D, a design that is very credible, because as I've told you, there is absolutely no pleasure in making things that doesn't work.
Yeah.
And also it is my personal challenge. The reason I do this kind of project is because I like to have a challenge and also self-educate.
Yeah.
There is, I think a job that which you can learn new things. It's not a good job. You have to have a job that you can always learn new things. And this kind of project always push myself to learn and to practice and to challenge a new criteria, new difficulties.
Yeah, indeed. And would it be like a dream to one day really produce it? Or would you like to discuss it with one of the existing plane companies to get their feedback? What would be your next step of personal reward or satisfaction in the project?
Yes, I think it's certainly, I think the advantage of having the internet connection these days with all different kind of social media is that you can always publish your work. I wouldn't necessarily look for somebody to build it, but if somebody is interested, that would be a great plus. So
okay.
Yeah, of course, yes.
Yeah.
So yeah, I think that would be an extra plus for this kind of a project, even though I'm not necessarily looking for it.
Yeah, indeed. Just to get in talks with passionate people in the same segment, then let's say.
Absolutely. Already, I have found a person like yourself, which is already in that sense only. I've already earned something.
Yeah, true. Yeah. Same for me. It's been interesting to see what people do beyond their jobs, and in your case, yes. It's still designing.
Yes, absolutely. Yes.
Yeah. Okay. No, it sounds very cool. I'm really looking forward to see it evolve and to see how the shape and also the aerodynamics, of course,
yes.
take shape. And do you think it would make sense to one day maybe build a scaled prototype just to fly yourself remotely? Of course, it's not the same. Not everything scales the same, but maybe that could be a cool intermediate step.
Actually, I do have a little 3D printer at home, and I'm actually toying with the idea that at least some part of this aircraft could be built in combination of the balsa wood and 3D printed materials and the traditional RC model materials, and actually build a plane a scale model plane that works. That is in my plan.
Okay.
Yes.
And I guess then the things you can make or 3D print yourself, that takes time, but you have time and passion. But the other challenge would be the standard components, like especially the rotor motor. That would be something to look for, a standard component that fits well enough with your plane, and it might even decide or determine the actual scale of your model to fit within the motor then, I guess.
It would be really good if I can print electric motor the way I want to. I'm quite sure that would happen one day.
Yes.
But for the moment, I'll have to think about how to integrate an existing electric motor in this package. One thing I can think of is basically to make a bridge from using the fan, the ducted fan, creating a bridge from the main fuselage to tail. that is, and use a standard motor here and put it here. That could be one possibility.
Yeah, and another would be to not put the motor on the center fuselage, but use the outer ring of the duct that you have. But that would make it a very expensive motor, I guess.
Yeah, I think so. I have thought about it as well. In fact, I have thought about putting the motor on the outer housing of the duct and make the propeller sort of hang down towards the center.
Yes.
but I think that would be kind of pushing it too far. I think.
Yeah. Okay.
Yes. Otherwise, I've been also looking at your the test result, and I've noticed that at the moment the wing compared to the center line of the airplane, I've got zero angle of attack, and thanks to your advice, I now know that with using the same profile, I have to put 4 degrees. To have the ideal lift and drag coefficient. That's right.
Yes, indeed. Something we concluded when we were looking at the theoretical lift curve of the airfoil that you use. Of course, it can generate more lift. That is what we saw, which can be handy for takeoff and landing. But for the most efficient flight, we looked at the lift over drag ratio, and that one seemed to be the highest at around 4 to 5 degrees. So indeed, it would make sense to give the wings at least some kind of angles to start with. Or an alternative would be to put the center of gravity a bit towards the rear, which would make the plane tilt a bit upwards a bit. But then again, that would not be the most efficient, because then the tail needs to compensate for this all the time. So indeed, just giving the main wing a 4 to 5 degrees angle of attack would make sense, I would say. Yeah.
Yes. So I think, because when I looked at the test result which you have sent here, the first thing, of course, the speed of the plane is too low. I've set it to 100 kilometers an hour.
Yes.
And this kind of type of planes normally cruise at 160 or 200 even.
Okay.
So 100 kilometers an hour, I think is 28 meters per second is too low.
Yeah.
And with 4 degree angle, I think you have stated that it creates how much lift? About 350 kilograms of lift.
Yes,
I think.
Indeed, which would be the order of magnitude of the planes that you mentioned that already exist in the market today. So that should be something feasible.
Yes.
Yeah, indeed.
So having this kind of test and your help, of course, professional help, already gives me a very good idea if I'm on the right track or not.
Yeah.
So thank you very much.
No, you're welcome.
Yes, I found that the other figure which I thought was very interesting was the. I think I'll have to look for it here. I think how much power. Yes, this one. I find this one very, very useful. The power required.
Yeah.
At the meters, 4 meters per second. So here I can see that about 28 meters per second. It needs how much power. With this, I can more or less guesstimate how much power I would need to power how much power. From the sun is needed to keep it afloat.
Yeah, indeed. And like you said, this value is for the zero angle of attack, and for a speed that is a bit low. If you would increase angle of attack and then speed, then probably this value would go up. But still, like you say, you have a first feeling of the order of magnitude, and then you can know whether you need 10 times the wing size for solar panels, or if you're in the same or the right ballpark already.
Yes.
Yeah, indeed.
And another thing I've noticed about your result is that it's very, very comprehensive. I've never seen such a simple to read results before with the graphics and everything. It's all very, very neat. So
okay, thank you.
I have to say it's very designer friendly.
Yeah, well, that's basically the background, because my training is engineering, but I worked at a design and engineering company for around 6 years after I worked in the wind turbine industry. And there indeed, you really notice that it's not just the technical result, which needs to be very good and professional and accurate, of course, but the way you present it is also part of the way you interpret technical data, and to make it comprehensive is a bit of a challenge. Usually I have the typical engineering flaw to put it full of details, but too much detail makes you lose the overview. So we had to scrap a few things to make it comprehensive like this.
That's because I have some experience of testing some aerodynamic software myself, and sometimes already trying to just set up the whole procedure is not that easy.
Yeah.
And even though I have got the result, I just don't know how to read it because there are numbers everywhere, and there's no sort of a graphical clues at all. So those kind of things can be very, very off-putting for designers.
Yeah, for sure, indeed.
Yes.
Yeah,
so it looks like I have to like dive into this the swarm of numbers and find a clue, and it's almost impossible.
yeah, indeed, and that is why a typical scenario is that a designer needs to wait or queue at the aerodynamics department to get feedback, which would overload that department. So indeed, we want to empower designers to already do part or even the whole of the aerodynamic analysis, and then go to their aerodynamic counterparts and already show them the first results of their design.
Another thing I found very interesting, here we can see better. Green part means that it's not getting any pressure. Does that mean?
Yes, it would be, if you look at the green, it's around the neutral pressure. Of course, you have the atmospheric pressure, but this is the relative pressure versus the atmospheric pressure. And indeed, it means that, like the fuselage, for example, it doesn't generate a lot of negative or positive pressure. And if you're looking at the tail, for example, that's normal, because the tail would, if your center of gravity is positioned nicely between the two main wings, your tail doesn't need to produce a lot of lift or downforce to keep
which would create
stable.
drags.
Yes, which would create drag. So indeed, it's a good sign that you don't have a lot of overpressure or underpressure on the tail. They should only generate that when you want to do
maneuvering.
a maneuver. Yes, indeed.
Yes. So basically, it means that I have angled the rear tails in a correct position, which will not be which will not be creating drag. So
yes,
correct. So I'm very proud of this part.
Yeah, yeah, indeed.
Yes.
Yeah.
Okay. Another thing I thought was very interesting was the noise, because in car design world, aerodynamic is also used a lot to sort of find out which part of the car body is creating noise.
Yeah, indeed.
And I think it was here.
Yeah, and here again the story is the same. You would have to. I will send you a car report after this call, and there you can see that it's the wake of the air is full of noise generation, because what we do here is we estimate. So it's a very first rough estimate of how much noise is generated, and it's based on the kinetic energy and the turbulent energy that is in the flow, that is then dissipated in the form of noise. And normally this happens within the wake of an object. So imagine you have a mirror on a car. In the wake of that mirror, you would start to see that this kinetic and turbulent energy, of course they are related, is being dissipated into another form of energy, which can be heat and can be noise. So typically that is what you see, and mirrors are a typical focus point for cars, as are the wheels and the wheel arches, where the noise reflects a lot.
Absolutely, yes, and also the A-pillars, around the A-pillars, because it has got this sort of a rather sharp edges, which creates less of noise.
Yeah, indeed. Yes. Yeah, that's correct. Thanks a lot, Yong Wook. It's very interesting to see what you've been working on in the airplane. And I would say keep us up to date over the next months. And if you have advances in design, I'm really looking forward to putting it into the tool again and to see what the differences have been.
Absolutely, and thanks very much for thanks very much for your time and all the time you have spent for this project.
So that was it for this video on airplane design. If you have any questions or comments, just let me know and I'll get back to you as soon as possible. Thanks for watching. See you soon. Bye bye.